This is Algebra 2 with trig, 2b.2a. We're going to add and subtract, we'll multiply polynomials. Here we have two sets of parentheses. A lot of people make a mistake and they FOIL or multiply this all together. That's not going to happen here because we are adding the two groups together. So really, you don't need the parentheses at all. You could rewrite it, or you could just take a look and say that you have 4x cubed and, or plus, you have a negative 5x cubed. So that's going to give you a negative x cubed. 4x squared and a negative 2x squared will give you 2x squared. Negative 3x and a negative 4x is going to give you negative 7x. 10 and negative 4 is going to give you 6. Notice we did not change any of the exponents. The exponents only change when we're multiplying the common base. Here we're adding, so we add the coefficients. Here we are subtracting two polynomials. In subtracting, you typically do want to distribute that negative in. So now we're going to have 3x cubed plus 4x squared plus 7x plus 12, a positive 4x cubed, negative 6x squared, minus 9x plus 3. So now we're going to combine like terms. I often like to put a line through the ones that I've already calculated. So negative, actually 3x cubed and a positive 4x cubed gives me 7x cubed. 4x squared and a negative 6x squared gives me negative 2x squared. Positive 7, negative 9 gives me negative 2x. 12 and 3 give me 15. So by collecting your like terms, we can simplify our polynomials.
Wait, so what matters, the order you write it?
The answer should be written in standard form. So that's when you write the answer in the largest exponent first and decreasing order after that. This is the same type. It's just a different notation. Here we're going to take f of x and we're going to add it to g of x. F of x, we look up in our given information, we see 4x cubed plus 9. And we're going to add that to our g, 3x squared minus 4x minus 2. If we're adding the two polynomials together, parentheses are not needed. We have 4x cubed plus 3x squared minus 4x, and our like terms will give us positive 7. Here we're looking for h of x. H of x is 3x squared minus 4x plus 7. And we're going to subtract. Now you should be more attentive when you see subtraction. Subtraction is going to be a tougher problem. More people get it wrong. Because when you subtract, you have to subtract the whole quantity of 8x plus 2x squared minus 3 plus 9x cubed. That's implying that you have to distribute that negative through. It's going to go to every term. So I'd rewrite this again, writing this as negative 8x, negative 2x squared, positive 3, and a negative 9x cubed. So then you can collect like terms. Our largest exponent goes first. That's going to be this one down here. So I'd cross it off just to remind yourself that you've used it. Negative 9x cubed. 3 and a negative 2 gives me a positive x squared. Negative 4 and negative 8 give me negative 12x. And a positive 7 and a positive 3 give me a positive 10. So next we're going to come down, and what operation do we have here? This is multiplication. So your f function is x squared minus 2x plus 3. And for us to show that it's going to be multiplication, we need to write parentheses. You don't write an x, that's for sure. X minus 5. Because that's my g function. So you go ahead and try to multiply this. Just like FOIL, but it's got an extra step. It's an extra term to multiply through. So you should pause the video, work through this problem on your own, and then come back and watch us work through it. So what we're going to do, you can go either direction. You can take your x and multiply into the trinomial, or you can take your trinomial and multiply into the binomial, your choice. I would prefer to go from the binomial, but I would usually like to write that in front. The order doesn't matter how you write it, but I won't change it here. We'll just take the x squared and multiply. That's going to give us an x cubed, because when you multiply x's, you add exponents. X squared times negative 5. Then we're going to take the negative 2x and multiply. That gives us negative 2x squared and a positive 10x. Then we'd come through and do the same calculation with our 3. So we're going to get 3x and negative 15. So you have a final answer by collecting your like terms. The largest exponent is our 3. Then we have 2x squareds, which gives us negative 7x squared. We have 2 x's, which gives us 13x. And we have the negative 15. All right, come down to this next one. We're really not learning anything new, but we are addressing these different properties. How do you multiply a binomial, or let's call it, how do we raise a binomial to the third power? Go ahead, pause the video, work through this one, and come back and watch us fill it out. So to multiply this out, the hint is that we'll be working with 3 different binomials. Now the common mistake here, people are going to call this 4 cubed, which is 64x cubed, minus 27. That's the common mistake. You cannot distribute that through. You have to write it 3 times because you are cubing this binomial. Then we're going to multiply 2 of them together first. Then we're going to multiply by the third one. I typically like the binomial to be in front. So I'm going to work with these two first. 4 and 4 makes 16, so we have 16x squared. When you multiply x's, you add exponents.
Oh wait, you're not to the point I'm at.
4 times 3 is negative 12. This side would be 4 times 3 is negative 12. And 3 times 3 is positive 9. That whole polynomial is going to be multiplied by 4x minus 3. Now we can simplify this together first by collecting our like terms. Now we'll come through and multiply by the 4x to all three terms, just like we did in the previous problem. So the 4x, 4 times 16. Well, 2 times 16 is 32, so another pair of that is 64. 64x to the third power. 4 times 20 would be 80, and then 4 times 4 would be 16, so this is 96. And 4 times 9 is 36. That's going to be 96x squared, because when we multiply x's, you add the exponents. This one's going to be 36x. We have one x here, and we have no x's over there, so it's just x to the first power. Then we come through and work with our 3. So we get negative 48x squared. Positive 72x. And negative 27. So that's going to give us 64x cubed. Then we have 96, and we have another 48. That's going to be a negative 144x squared. Plus 108x, and our negative 27. So we were able to multiply that all out, collect our like terms, multiply again, collect our like terms, to get our final cubic question, because this was going to be a cubic from the beginning. A cubic's always, not always, but a cubic can have 4 terms. If it has every term represented, it has an x cubed, an x squared, an x, and a constant. All right, flipping our next page. Now here, I hesitate to remind you about your patterns. Typically, we take our binomial and we talked about the shortcuts of factoring into this format. These are called conjugates of each other. And if we foiled this together, we would get x squared Let me try that for you. If we would multiply this together, we would get a squared, a negative ab, a positive ab, and a negative b squared. These can combine together, and you notice that they cross out because one's a positive ab, the other one's a negative ab. So you're left with a squared minus b squared. That's going to happen for every set of conjugates. These are conjugates because the terms are the same, but the signs are different. So it's a squared minus b squared. We typically go the other direction when we're factoring. I hesitate for you to memorize that because I'm afraid For other problems, you'll try to apply the shortcut, and you'll only multiply the A times the A and the B times the B, and you won't do the whole FOIL. So in other problems, you'll miss out on the O and the I. So let's try that. If you're going to use the pattern, you would just say the 5y is going to be squared, and the 3 is going to be squared. So that's going to be 25y squared minus 9. And you're done. You're just using the pattern. You recognize that these are conjugates of each other. You don't have to do the whole FOIL portion of it. Here's another one where we could just call it 9h squared plus 4, or minus 49. That's the answer. But if you use the FOIL so that you don't have to recognize so much, 3h times 3h, 3h times negative 7 is negative 21h. This would produce a positive 21h. Then you get your negative 49. So the correct answer is 9h squared minus 49 because these terms cross out. So the shortcut is just to multiply the front and just multiply the back. That only works for conjugates. Now we're going to look for perfect squares when you're squaring a binomial. There's a pattern for that. The pattern for multiplying here, you already know what it is, but you know that you would have to write it twice, you would have to multiply it out. Here's another positive AB, and then B squared. So our pattern is A squared plus 2AB plus B squared. So that's the pattern that comes when you are squaring a binomial. You square your first term, you times 2 times the product of the two terms, and then you square your second term. So you can use that pattern by saying the 4a should be squared. This is a plus, so I'm going to use a plus. 2 times 4a times 7, and then I square my final term. So that gives me 16a squared. 28 times 2 is 56a plus 49. So there's a special pattern. You can use that as a shortcut if you think that's better than foiling it all together. Over here, I'll just reinforce the foiling part. Here, look at the notation. Look at what it's asking. They give us the f of x, and then we're supposed to square f of x. So we're going to take our 9x minus 2, and we're going to square it. Well, to square that, that should be 9x minus 2 times 9x minus 2. We could use our pattern to multiply that, or it's just fine to FOIL this out. Minus 18x and another minus 18x, that gives us 2 times 9 times 2, and this is a positive 4. So this is 81x squared minus 36x plus 4. So that's using FOIL, which is just fine, or the special pattern to square a binomial. And up here, we're using the pattern to multiply conjugates, or you can just use FOIL to multiply conjugates. Your choice. All right, coming down to our multiple choice. The models below are D is the model and C is the model. they give the average depth of a new well that's drilled. So here's the depth. So in a certain time, this would be your average amount. So it looks like every year the average depth is a little bit farther. And then C is the cost of drilling a new well. So as your years increase, this is going to create a larger and larger amount because the cost keeps going up. What operation would we use? Would it be addition, subtraction, multiplication, or division? So what operation would we use to model the average total cost of drilling a well? Think about what that means. You're going to drill a well, a total cost. It's kind of like our maximum revenue question, where we took the number of items, that would be this, the feet that we're going to drill, number of items, times the cost of how many items we have. That would give us the total cost of what we're doing. So D times C, it would be a multiplication calculation, not an addition, subtraction, or division. You need to take every foot that you do and figure out what the cost is, so you'd be multiplying it with the cost. Number 16. Every value is not included here. So this should be a 3x plus 4 and 2x minus 3. You need to be sure to add the extra parts to your figure. This is called a pyramid. It's a square pyramid. A pyramid is calculated by the height. So the volume is 1/3. Capital B refers to the area of the base. This base is a square. So we do length times width times the height. So our volume is going to be 1/3 the base squared, that means write it twice, times the height. Well, one of the properties we learned about was if you're going to square a binomial, you can multiply your first term to itself, so that's 4x squared. Multiply the two together to get -6 times 2 is -12x. And 3 times 3 is 9. Now here I can't really distribute my 1/3 through because it doesn't go into the 4, so I probably won't do that here. So now we'll have to multiply back through one more time and probably collect like terms one more time. 4 times 3 is 12x cubed. 4 times 4 is -16x squared. -36x squared. Positive 48x. Positive 27x. And -36. So this is going to give us 1/3 12x cubed. Our x's go together to be 52, -52x squared. 55, sorry. Well, not even that. This is 60 plus 15 more, that would be 75. Plus 75x minus 36. And it does look like 3 goes into every one of those. So your total volume is going to be 4x cubed minus, 4 doesn't go in, 3 doesn't go into that. So that's a bummer. 52 cubed, or 52 divided by 3. It does go into this guy, and it does go into that. So anyway, either one of these two models would be fine. I distributed it through. Since it didn't go in there evenly, I just wrote it as 52 over 3, but it went into all the others, and I divided those all by 3. Here's our last little geometry project here. We want to know the area. So this kind of looks like a pool to me. We have the pool area. We have all of this deck space, but we have the water space. So how much decking is there around the pool? How do we determine that? What is the area of the shaded region? Go ahead, pause the video, give this a try, and then come on back. I'll walk you through it. All right, looking at my last problem, this was 3x plus 4. I used 3x minus 4. You would get a different answer, but the process is all the same. 1/3 the area of the base times the height. That's the volume of this pyramid. Down here for the surface area, we're going to take the dark region minus the light region. So the dark region is length times width, which is x plus 1 squared, minus the lighter region is 5 times x minus 7. And often we might have another set of parentheses just to show that we're minusing this whole group. You really don't need that extra set, but just so you understand, you're subtracting that whole quantity. This is going to become x squared plus 2x plus 1. This will be a negative 5 times x and a negative 5 times negative 7. So our final term is going to be x squared minus 3x plus 36. That is the area of the shaded region. Okay, I use the term dark region minus. This would really, I guess, the best terminology. It's not, that's what we're looking for, is a dark region. This is the total region. That's the total area minus the light gives us the dark region. Be sure my terminology was right there for you.